Hello again guys, this is the last video for Year 10 triples. So this is for week 5, week commencing the 6th of July, your chemistry lesson that week, which is looking at a process called cracking. We will get to that in a moment. We'll just quickly have a recap of what we did in the last session, the last chemistry video. Hope you're all still safe and well, and able to be at least looking forward to the summer holidays and whatnot, although it has been a slightly disrupted last term, obviously, to say the least. So, 5 quick questions. I don't know why the one is so little, but anyway. Pause the video, have a go at those, and then we'll go through them. Okay, so number 1, what do we call the process used to separate crude oil into the compounds it is made up of? We call that fractional distillation. We spoke about that last lesson, where you heat the crude oil till it all vaporizes and then you allow it to condense back into liquids at the different boiling points of the different fractions, and they can then be collected as separate substances. Number 2, what do we call the different parts it's made up of? We call them fractions. Number 3, what is different about these fractions? Their boiling points. That's how they are separated, because they all evaporate and condense at different temperatures. If you vaporize the whole mixture and then pass it through a fractionating column, which has a temperature gradient, it gets hotter as you go down the column, you can then collect the different fractions at different points in the column. Number 4, name one fuel we can extract from crude oil. There are several: diesel, fuel oil, kerosene, gasoline. Number 5, a substance we can extract / make from crude oil that is not a fuel. A good example of that is bitumen. It is one of the larger fractions that is removed at the bottom of the column. A very thick, viscous substance, not very easy to light, but very useful for, well, we use it for making things like roads and things like that. Okay, so moving on to look at cracking, which looks at what we do with some of these fractions once we have obtained them. Okay, you have the fact book bullet points that you need to cover. That's what we're going to be looking at in this session. Okay, so cracking. Most of the fractions we obtain from fractional distillation are actually not very useful. A lot of them are long chain molecules, so long chains of carbons, that result in thick solids or very thick liquids. They're very high boiling points, they don't catch fire easily. So in terms of what we want to use them for, which is predominantly fuels, they are not particularly useful. So there is further processing needed in order to make these large long chain hydrocarbons useful, and that process is what we call cracking. So we can break down these long chain molecules into more useful shorter chain molecules using this process, cracking. They are vaporized again and then passed. There's 2 ways of doing it. You can either pass them over a hot catalyst, which will break them down into smaller molecules, or you can pass them through steam, which will break them down into smaller molecules. So there are two ways of cracking long chain alkanes: either catalytic cracking using a catalyst, or steam cracking, which is basically using a really, really high temperature. So for example, if you have a molecule of decane, which is 10 carbons and 22 hydrogens, if you remember the general formula for the alkanes was CnH2n plus 2. So if you have 10 carbons, you have twice as many hydrogens, which is 20, plus 2, 22. So we can crack decane to make shorter chain hydrocarbons. Okay, so we could make, for one example would be, we could produce C5H12, which would be pentane. Pentane is the alkane with 5 carbons. But we also make 2 other substances. We also produce other substances when we do this. Now you'll notice these have a slightly different ending. Rather than being propane and ethane, they are propene and ethene. And if you look at their formulae, you'll see a difference as well, because rather than being CnH2n plus 2, they would just be CnH2n, because you've got twice as many hydrogens as carbons in these molecules. Now we'll look at that in a bit more detail in a second. Okay. So an example of how you might do this in the lab, classroom, to demonstrate it, you have the long chain hydrocarbon, you heat it, it vaporizes, pass it over a hot catalyst, in this case aluminium oxide, and that causes it to crack or split into these different molecules. And then from that, you, in the lab anyway, could collect it through water to make sure you get a pure sample. So, if a catalyst is used, we call it catalytic cracking. You can also use it by mixing it with steam, which is a very high temperature, and that breaks it down into smaller molecules as well. That would be called steam cracking, or sometimes called thermal cracking. Now, because it uses heat to break something down, cracking is what we call, is an example of a thermal decomposition reaction. Thermal is heat, decomposition means breaking down, so a thermal decomposition reaction means using heat to break something down. Okay. Now, in both types of cracking, the heavy fraction, or the large molecule, is vaporized and then either passed over a hot catalyst or mixed with steam, which results in the thermal decomposition we've been talking about. Now, the products of cracking are short chain alkanes, but you also get, as I said, other types of hydrocarbons called alkenes. So you break down the long chain hydrocarbon and it will break down into a shorter chain alkane and a longer chain and another small molecule called an alkene. Now the difference you'll notice here is in an alkane, all the bonds are single. So as we said last session, that means it is a saturated molecule. You cannot fit any more hydrogens into that molecule because all of the carbon's bonds are single bonds. In an alkene, you have a double bond between two of the carbons. That means it is what we call an unsaturated molecule. If so required, you could open up that double bond and attach something else to the bonds. Okay, so it is not completely full up, as it were. It is not saturated. It is unsaturated because it has a double bond. Okay, so alkenes contain at least one double covalent bond, and because of that we call them unsaturated hydrocarbons. So if there's a double bond, it is an alkene. No double bond, it is an alkane. Now that changes the general formula. Alkanes, remember, have the general formula CnH2n plus 2. So however many carbons there are, there'll be twice as many hydrogens plus 2. Alkenes have the general formula CnH2n. So however many carbons there are, there will be twice as many hydrogens. No plus 2 because of the double bond, which means there are fewer hydrogens per carbon. Okay. So the two pieces are not the same. One is an alkane, but the other ones will be an alkene with a carbon-to-carbon double bond, and it is unsaturated. So, for example, decane could be split into C8H18, which is octane, that's the alkane, and C2H4, which is ethene, which is an alkene, because it only has twice as many hydrogens as carbons. So looking at it there, there's octane, 8 carbons, 18 hydrogens. There's ethene, 2 carbons, 4 hydrogens, because of the double bond. Likewise, you could split decane into heptane, C7H16, and propene. And again, there's heptane, 7 carbons, 16 hydrogens, and there's propene, 3 carbons, but because of the double bond, only 6 hydrogens, whereas propane would have 8 hydrogens. Okay, likewise, you could split decane into hexane and butene. So again, hexane has 6 carbons and 14 hydrogens. Butene has 4 carbons, but only 8 hydrogens because of the double bond. So alkanes are saturated, alkenes are unsaturated, alkanes have the general formula CnH2n plus 2. Alkenes have the general formula CnH2n because of that double bond. So, naming these then, it's exactly the same process. You need to remember the names of some of the alkanes. If it's got 3 carbons, and it would be propane, because it's got a double bond, it is propene. If it's got 4 carbons, it would be butane, but because of the double bond, it is butene. Again, 2 carbons, if it's an alkane, it would be ethane. This one has a double bond, so it's ethene. And 5 carbons, if it was an alkane, it would be pentane. This one has a double bond, so it's pentene. Going back to the diagram of how you might do it in the lab, the bromine water, well, that's not in the diagram, but bromine water is how we test for an alkene. Okay, alkenes are more reactive than alkanes because they have a double bond. So when you react an alkene with bromine water, it will take the bromine water, which is a kind of orangey colour, and it will make it colourless. That is how we test for an alkene. If you pass an alkene through bromine water, it turns the bromine water colourless. That is how you test for an alkene. The aluminium oxide in that setup was the catalyst, which makes the reaction work more easily. Okay, now the smaller alkanes that are produced from cracking are much more useful because they make much better fuels. Because if you remember, the smaller the molecules in an alkane, the easier it lights, and the more easy it is to pour, etc. The alkenes that are produced can be used to make other substances. So the smaller hydrocarbons are used for fuels, the alkenes are used to produce polymers like polythene and things like that. They are also used as starting materials for the production of other chemicals and other things that we use. So, if you want to pause this and have a go at filling in the gaps. So, you should read crude oil separated into several different fractions using fractional distillation. This separates hydrocarbon molecules by their size. Small molecules have lower boiling points and are collected nearer the top of the fractionating column. These small hydrocarbons make excellent fuels. Large hydrocarbon molecules have higher boiling points and are collected nearer the bottom of the fractionating column. These are less useful because they do not burn very well and so do not make good fuels. Cracking is a process used to break these large hydrocarbons down into smaller molecules so that we can use them as fuels. Okay. Now there's a little summary video there. Just as a point, when you're watching the video, they will talk about thermal cracking. That's the same as steam cracking. But steam cracking is the terminology, the example that we'll use. Okay. So there's the key facts. Cracking creates more useful short-chain hydrocarbons from less useful long-chain hydrocarbons. Cracking alkanes also creates an alkene. Cracking is a thermal decomposition reaction because it uses heat to break down large hydrocarbons. And there are 2 main methods, catalytic cracking, which uses a catalyst, or steam cracking, which just uses steam at a very high temperature. Okay, I hope that's been of some use to you. Thank you.